We are now going to learn how to do a one-sample t-test by hand. And here is the example that we are going to use. We read a story in Martha Stewart Correctional Quarterly that tells us that the average national score for women on a test of indoor gardening is 73, but no standard deviation is provided. We want to know how men will score on this same test. So we sample a random selection of 9 men, and we compare their sample mean of 65.67 to the population mean of women. The sample mean is assumed to be pulled from a population of men who have the same mean as women, i.e. 73. So we sample 9 men, we get a sample mean of 65.67, and we start with a null hypothesis that the men's mean is the same as the women's mean, 73, or that there is no difference, mu equals 73. And so let's work through our 5 steps of hypothesis testing to make sure that we've covered each one. The first, select the appropriate statistic. Well, we are comparing a sample mean to a population mean where we do not know the population standard deviation, and in that case we always use a one-sample t-test. Our null and alternative hypotheses, step 2. The null hypothesis is going to be h sub 0 colon that mu equals 73, or men are drawn from a population with a mean of 73. Same as the women, no difference. And the alternative hypothesis is mu does not equal 73, that the men come from a population that does not have a mean of 73. But we are not saying which direction they will change, will they be greater than or less than, only that they will be different. Step 3, select a level of significance. Are we going to use a one- or two-tailed test? What alpha level are we going to use? Well, we always assume a two-tailed test with an alpha level of 0.05 unless we're told otherwise. So we'll start with that. But we also need to calculate degrees of freedom. Degrees of freedom is simply n minus 1. How many men were in our sample? 9. So how many degrees of freedom will we have? N minus 1, or 8. What we can then do is go to our t-table and look up a critical value for a two-tailed test with an alpha of 0.05 and 8 degrees of freedom. So let's do that now. On the last page of your one-sample t-test notes, you will find this student's t-distribution table. These are the critical values for the t-distribution. What you will notice is that there are 2 big columns, and then each of those have, we'll call them sub-columns within them. On the left, we see values for a two-tailed test. On the right, values for a one-tailed test. We are using a two-tailed test at an alpha of 0.05. And so if we start in the columns on the left, we will find a column for alpha equals 0.05. Also on the left, we see degrees of freedom, df, and those start with 1, 2, 3, 4, and go all the way down to 30, 40, 50, 75, 100, 200, and infinity. So why do we have sample sizes that go from single digits, 1, 2, 3, 4, 5, up to 30, but then take jumps of 10 at a time once we get past 30? Well, this goes back to something we've learned previously about sample sizes. Once we get above 30, the changes for each additional participant are very small. So notice that the critical value for degrees of freedom 29 is 2.05, for 30 is 2.04, for 40, 2.02, for 50, 2.01. Adding 10 more people only shrinks your critical value by 1/100th of a point. So once we get beyond 30, the changes slow down dramatically. And look what happens when we get to infinity. The value is 1.96. That's the same as for a normal distribution or a z-test. Well, we have 8 degrees of freedom. Remember, degrees of freedom is n minus 1, and there were 9 men in our sample. So for a two-tailed test, alpha equals 0.05. With 8 degrees of freedom, our critical value is 2.31. All right, let's go back to our 5 steps. Sorry, need to make a little correction. The t-table that I just showed you used 2 decimal places for critical values, in other words 2.31, but the example that I'm going to show you now uses 3 decimal places. The number in the t-table was 2.306. So now let's finish out step 3. Our critical value we will write as a positive negative 2.306. We use positive negative because we're not saying which direction the alternative hypothesis will change. Well, now we are ready to calculate some statistics, and to do that, let me walk you through the steps. We're going to use Excel to calculate the standard deviation of the sample and the mean of the sample. So open up an Excel document. Let's create an X column first. Then we will square that value to create an X squared column. We'll add up both of those columns using summation and then plug them into the formula that you have in your notes. So step 1 is we'll create a data set on sheet 1. Then we'll copy that data to sheet 2. We'll compute our X and X squared on sheet 1. And then later we will import sheet 2 into SPSS. So let's switch over to Excel and get started. And here we are in Excel. I have enlarged the size of the cells to make them a little easier to see. So what you should do in your Excel program is start in cell A1, and we'll type the word men. And in B1, we'll type an X2, which is going to represent X squared. Now it's time to do some data entry. So let's put in the values from the notes. 50, 75. These are individual scores for each of the people who took that test. 72, 68, 65, 64. All right. To square these values, we're going to go to cell B2. We're going to type an equal sign. We're going to click on cell A2. Gives us that in the formula. Shift 8 is an asterisk. Click again on A2. And that will square the value of 50 to 2500. Now click on the 2500 and grab that little handle in the lower right corner, drag it down, and that copies our formula. Finally, we're going to sum up these values. Let's start in cell A11, equal sign to type our formula, SUM for sum, open parentheses. We're going to drag from A2 to A10, close parentheses, and return or enter 591. We're going to do the same thing with the dragging. We're going to grab that handle in the lower right corner, drag it 1 to the right, and now we have an X squared value. I like to make these values bold just to set them off a little bit. We'll do the same thing on the top row, make those bold, maybe center those. All right, looks good. In fact, let's just center all of this. Good. So now we have these values. I do want to take the values that are on sheet 1 and copy them to sheet 2. So the first thing I will do is start with A1. I'm going to click and drag, grab just the values, not the summation, not the 591. Command C, Control C, right click, copy. And now we need to create a new sheet. There's sheet 2 and paste. You notice these cells are much smaller. I can increase the size of the cells with magnification. That's what we find on sheet 2. We're going to use those values later to import into SPSS. Finally, save this data set to your desktop. Command S or Control S, save, and I'm going to call this, and we'll save that to the desktop, and we'll know where to find it later. So the values that we are going to need for our formula will be this 591, the 39, 289, and of course our sample size, which is 9. Let me show you how to do this math on your calculator. If you've forgotten how to do this, go back to the variability chapter where I give you a step-by-step walkthrough of how you will do this math. So we need the sum of x squared. The sum of x is 591. And then I'm going to click on x squared to get that value. I'm going to divide that by n, so divided by 9, not n minus 1 here, n. And that's 38,809. I'm going to put that into memory, so memory plus. Okay, I'm going to clear that. Now I need 39 289 minus, and memory recall, equals 480. All right, so that is the numerator. We're going to divide 480 by 8, which is n minus 1. Leaves us 60, and finally the square root of that is we'll round that to 7.75. So by plugging in the values that we calculated in Excel into our standard deviation formula, the one with the n minus 1 correction, we came up with a standard deviation value of 7.75. Now here's another hint. If you'd like to check the math, you can also go back to Excel and use this formula. It's equal sign STDEV, and then the range, A2 to A10, the range of our data. You'll also get 7.75. All right, so SD equals 7.75. Let's divide that by the square root of n, and we get 2.58. The square root of n, of course, being, well, n is 9, and so the square root would be 3. And finally, we plug that value into the denominator of the t-test formula, the mean minus the mean of the sample minus the mean of the population divided by the estimated standard error of the mean, and that value is a negative 2.84. Let's go back to the calculator and let me show you that math. So here's how I did the math for the t-test. Our standard deviation was 7.75, which I divided by the square root of n. N is 9, square root 3, equal sign. That is 2.58. That 2.58 is going to go into our t-test formula, where we subtract the mean of the sample, 65.67, and subtract from that the mean of the population, 73. Equals a negative 7.33 now, divided by 2.58 equals a negative 2.84. Now that we know where our negative 2.84 value came from, let's go back to our 5 steps and put that into context. So we are on to step 4, calculate the statistics. We calculated a t-value of a negative 2.84. Now it's time to make the decision. Does the t of negative 2.84 exceed the critical value of positive or negative 2.306? And the answer is yes, it does. A negative 2.84 is further away from the mean. It exceeds a negative 2.306. So men score significantly lower than women on a test of indoor gardening. T with 8 degrees of freedom equals negative 2.84, probability less than 0.05. Let's see how we would do this as a write-up in APA style. Here's what we would say. A one-sample t-test was conducted to determine whether men with a mean of 65.67 scored differently than women with a mean of 73 on a test of indoor gardening. The results were statistically significant. T with 8 degrees of freedom equals negative 3.62, comma, probability less than 0.05, comma, indicating that men score significantly lower than women on a test of indoor gardening. This suggests a gender difference in gardening skills. Here are some guidances for how to do this write-up in APA style. You'll find them on page 11 of the Bear handout under Reporting Your Results using proper APA style. And I give you 6 steps to writing up your write-up. If you follow those steps, you will be sure to include everything that you need for an APA style write-up.